Hello, everyone, and thank you for joining us this morning for the seventh week of the RISE Institute and Rugby Research and Injury Prevention Group 2026 Sports Science Series. We will begin with our first sports science presentation. Our first intern to present is Julia, and she will be presenting on heart rate variability. Julia, may you please share your screen?
Hi everyone, good morning. Thank you so much, Erin, for the introduction. I'll share my screen now. Thank you so much, Erin, for the introduction. My name is Julia Salim Viviani, and today I'll be discussing the paper Training Adaptation and Heart Rate Variability in Elite Endurance Athletes, Opening the Door to Effective Monitoring by Plews and colleagues. This paper exposed whether heart rate variability Surveys for whether heart rate variability, or HRV, can be used to monitor training adaptation and help athletes perform at their best. While HRV has become increasingly popular among coaches and athletes, this paper shows that interpreting HRV, especially in elite athletes, is much more complex than simply saying higher HRV is better or something in those sorts. Today, I'll explain what HRV is, how it changes with training, and what this paper teaches us about its effectiveness. So before discussing this study, it's important to understand what HRV actually measures. Many people think heartbeat occurs at perfectly regular intervals, but that's not true. The time between consecutive heartbeats naturally varies by small amounts, and HRV measures exactly this variation. According to the authors, HRV mainly reflects parasympathetic activity, which is a branch of the autonomic nervous system responsible for recovery and relaxation. Because HRV can be measured quickly each morning without invasive testing, it has become an effective tool for monitoring athletes over time. The paper first reviews how HRV responds to different training loads. In recreational and moderate in recreational and moderate training athletes, moderate endurance training generally increases both aerobic fitness and HRV. However, the training becomes extremely demanding. HRV usually decreases, suggesting fatigue and accumulation. During tapering, when training volume is reduced before competition, HRV often rebounds. This pattern has been observed in swimmers and distance runners, in this and this is one of the reasons why HRV has become popular for monitoring recovery. So, this figure introduces one of the paper's most important concepts, HRV saturation. Many people assume that as fitness improves, HRV will continue increasing. However, the authors explain that this relationship is actually quadratic rather than linear. Elite endurance athletes um, have extremely often have extremely low resting heart rates. At these very low heart rates, HRV can begin to decrease, not because the athlete is fatigued, but because the physiological responses has reached a saturation point. This means that lower HRV in elite athletes does not automatically indicate poor recovery or overtraining. One of the biggest methodological lessons from this paper is that HRV naturally fluctuates from one day to the next. Because of this normal variation, a single morning measurement may not accurately reflect an athlete's recovery or training status. The athletes recommended using weekly average or 7-day rolling averages instead, since these methods provide a more reliable picture of how the is adapting to training. This figure highlights another key message of the paper. The researchers monitored 4 Olympic and world champion rowers over 62 days before major competitions. And although every athlete won their event, their HRV pattern looked completely different. Some showed strong relationships between HRV and heart rate, while others showed almost none. This demonstrates that there is no universal HRV profile for elite athletes. Instead, every athlete has their own physiological fingerprint that must be monitored individually over time. Now, this figure compares 2 athletes preparing for the same international rowing competition. At first glance, both athletes showed decreases in HRV. However, when the authors analyzed HRV together with resting heart rate, they discovered that physiological meaning was completely different. Athletes A's HRV pattern reflected readiness to perform, and the athlete finished second. Athletes B's HRV pattern suggested poor adaptation to training and the athlete performed below expectations. This example illustrates why HRV should always be interpreted in context rather than in isolation. Based on evidence reviewed in this paper, HRV can be a valuable tool for sports medicine professionals when it's used correctly. Coaches and clinicians can monitor recovery, identify excessive fatigue before performance declines, adjust training loads, and help athletes arrive at major competitions in an optimal physiological state. However, the paper emphasizes that these decisions should always be based on a long-term monitoring and each athlete's individual HRV profile rather than a single measurement. To conclude, this paper demonstrates that heart rate variability is a promising method for monitoring endurance athletes, but only when it's interpreted appropriately. Rather than focusing on a single HRV value or practitioners should monitor trends over time, understand each athlete's individual physiological profile, and recognize that elite athletes often respond differently to other athletes like recreational athletes. Ultimately, HRV provides a valuable information that can help optimize training, recovery, and competition readiness when it's combined with careful, individualized monitoring. So this is my reference for the paper. If you guys are interested in reading a bit more into it, thank you so much. Are there any questions?
Thank you, Julia, for that excellent presentation. Are there any questions, or Dr. Lopez, do you have anything to add?
Anyone have a comment on that? It's a very important metric, heart rate variability. I think, its application or even more of its application, you can kind of avoid overtraining prevention. That's why, I really like this article and for us to understand, right? Didn't we discuss our workload is a major concern in our cohort? Excuse me. And let me rephrase that. Probably for all athletes, training in any capacity, heart rate variability and overtraining or workload, abuse, you find that these athletes are therefore not recovering with enough time and will mitigate, performance, metrics. I wonder, and this is something we probably could do in the future. We could probably look at those variabilities. All right, please, thank you. Next.
Our second intern to present is Elena, and she will be presenting on tactical and military athlete diets and their effects. Elena, when you're ready, may you please share your screen?
Okay, thank you for the introduction. Okay, is everyone able to see my screen? Okay. So today I will be presenting on the study, A Diet of U.S. Military Food Rations Alters Gut Microbiota Composition and Does Not Increase Intestinal Permeability. This study was written by Carl Armstrong McClung and colleagues and published in the Journal of Nutritional Biochemistry in 2019. So, as a bit of background, we know that the bacteria living in our gut and the food that we eat are constantly interacting. So, our gut microbes and our dietary components interact, and these affect intestinal permeability, or IP, and inflammation. The MRE, or meal ready to eat, is the standard combat ration for the US military. It is commercially sterile and highly processed, so it's shelf stable for years without refrigeration. This study looked at prior research, and this prior research had found that when people eat these rations out on the field during deployment, their gut microbiota changes and their intestinal permeability and inflammation increases. However, these studies were not able to separate the effects of the food and the ration itself from the environmental factors present in the field, such as heat, exertion, and stress. So this study was designed to isolate that variable. The aim of this study was to isolate the effects of a meal ready-to-eat diet on gut microbiota composition, intestinal permeability, and inflammation. This study was a controlled trial conducted in a research setting rather than an actual field deployment, unlike the past studies that it referenced. Because of this, the diet effects would be able to be separated from external factors. So this was a randomized controlled trial with 60 adults, mostly male, who were aged 18 to 61, and it was run by the U.S. Army Research Institute of Environmental Medicine. The participants were randomized into one of two groups. The con group or the control group ate their normal diet for 31 days. The MRE group only ate MRE rations for the first 21 days and then returned to their normal diet for the last 10 days. This is important because it allowed the researchers to see whether any changes reversed when people went back to their regular diet. So fecal samples were collected at baseline, during the intervention MRE period, and after the intervention period, and they were analyzed using 16S rDNA sequencing, which is just a standard way to identify which bacterial genera are present and in what proportions. For intestinal permeability, this was measured using a dual sugar absorption test on days 0, 10, 21, and 31. The inflammation was assessed using high-sensitivity C-reactive protein, or hsCRP, which is a common blood marker of inflammation, and LBP, or lipopolysaccharide binding protein. These are both markers of bacterial translocation. As secondary measures, SCFA, or fecal short-chain fatty acid concentrations, were measured along with GLP-2 concentrations, any reported gastrointestinal symptoms, and body weight. So in the control group, the body weight actually did increase over time, with a mean weight gain of 0.9 kilograms. However, in the MRE group, during the first 21 days of intervention, there was a mean weight loss of 1.1 kilograms. However, this weight was partially regained during the 10 days where they returned back to their regular diets. As for gut microbiota composition, longitudinal changes in fecal microbiota composition differed significantly within the groups. The researchers used a machine learning model called the random forest model. So they gave it bacterial abundance data and asked if it could identify just from someone's gut bacteria whether they were eating MREs or not. And these models correctly identified MRE fecal samples during the intervention period with 88% accuracy. This model also showed which bacteria were driving that signature. So lactic acid bacteria, including lactobacillus and lactococcus and lactonostoc, showed lower relative abundance in the MRE group. Genera that typically dominate the ileal microbiota were also strong contributors to the model. These went up. As for intestinal permeability and inflammation, despite this microbiota shift, intestinal permeability and hsCRP actually were lower in the MRE group compared to the control group on day 21. At every other time point, however, there was no significant difference between the groups. LBP, which is again the bacterial translocation marker, did not differ between the groups at any time point, and there were no clinically meaningful gastrointestinal symptoms that were associated with the MRE diet. So overall, the MRE diet had a marginal effect on the microbiota as a whole. The main effect was a reduction in lactic acid bacteria, which is likely from lower intake of lactic acid bacteria containing foods on the MRE diet. And this is because lactic acid bacteria from food can remain viable and metabolically active as they pass through the intestine. So these reductions in lactic acid bacteria were reversible um, after the 10 days that the MRE participants returned to their regular diets. And despite changes in the gut microbiota composition that would be expected to raise IP, increased IP was actually not observed. So overall, this trial was able to isolate the MRE diet from field conditions, and the authors concluded that any increases in IP seen in real deployment settings were most likely explained by environmental stressors such as heat, exertion, and sleep loss, rather than by the MRE ration. This study did have a few limitations. So because the researchers again wanted to isolate these variables, the study was done in a controlled facility, so it doesn't capture the effect of the combined effect of diet and environmental stress. Also, this sample was 95% male, and the intervention period was limited to 21 days of MRE only consumption. And lastly, these findings are specific to the US MRE ration, so they cannot be applied to all rations in general. So, in conclusion, a 21-day MRE only diet did measurably alter gut microbiota composition, and this was shown by a reduction in lactic acid bacteria. However, these microbiota changes did not increase intestinal permeability or inflammation. In some cases, the intestinal permeability and HSCRP were actually lower in the MRE group than in the control group. Also, reductions in lactic acid bacteria reversed after the MRE participants returned to their habitual diet for 10 days. Overall, these findings suggest that intestinal permeability and inflammation increases that were previously reported are more likely driven by environmental conditions rather than the MRE ration. And this is my reference if anyone would like to further look into this topic. Thank you.
Thank you, Elena, for your insightful presentation. Does anyone have any questions? Or Dr. Lopez, do you have anything to add?
Yeah, Elena, if you can go back to your, I think maybe the fourth slide from the end. I wanted to just briefly discuss Clostridium. Now it's called Clostridioides. In gut health. Keep going back. Go back. Go back.
This one.
Right there. So, the genera at the bottom, Veillonella and Clostridium. The issue is that now the Clostridium has various and all his gut bacteria have various genera and species, and what happens is that, to clarify, the species that everyone's very, very worried about in the hospital has the pre-name of Clostridium difficile was the old name. Now it's Clostridioides difficile. And like I said, you could even see with these words, you have to practice these words. They want you to know them even when they change them. So from Clostridium difficile to Clostridioides difficile. The point is, the difficile species is the difficult one, is the one that causes major diarrhea in the hospital, and it needs to be treated. But the Butyricum, that's the one that's very good for gut health. So I'm just wondering, they said that they showed higher relative abundance in the MRE group. I'm going to assume that it's the beneficial version, right, that they found for a good health gut versus the difficile, which is induces diarrhea, correct?
Um, I think I have
And
to
if
look
you
back
don't
into
know,
it.
that's okay. I'm going to probably just assume it is.
Okay. I think if anything, it might have been the negative one because they thought that it would cause more leaky gut.
Oh.
And it didn't, which is an interesting finding.
Okay, obviously, right? Anytime we're let's grasp this in a you can move out of this now. Thank you so
Okay.
much. I just want to make sure everyone saw the verbs or the wordage that they used. So let's just go over this. The MREs, right? These are the package they give these military personnel, and whether they go on a hike or a trek or a mission, this is all they have. And they used to package them, I think, in tin like tuna cans. But then what happens is that um, you left a trail of these, and then the enemies could follow you through the woods. According to my father was in the Vietnam War. What happens is they move to the paper version, so this way packaging or air tight packaging, so you can burn them, get rid of them, or maybe even carry them with you, so you're not leaving a trail for the enemy to find out where you were last. The point is that these need to last, right? Whether you get caught behind enemy lines, or you need to have a carry, or you get shot down. That's what the importance of these MREs, these rations, are all about. So let's talk about the more important thing is why do food okay, in the supermarket, does anyone know how the structure of a supermarket works? What's on the outskirts versus what's on the aisles?
There's produce on the outside.
Produce or perishables, right? Perishables are on the outskirts of a supermarket. So if you got to make that run, when you go into the supermarket, right, there's a certain, aisles mom and dad go through, and they go, in a certain order of things. So we know perishables are on the outside. Then the canned or packaged goods, what do they use in them for? What's the word I'm looking for? Shelf life. So what's the product that they put in the cans, Elena?
Just like preservatives in general.
Perfect.
But
Excellent.
I do have a question regarding that, just because I know some individuals that will like can things themselves and they go through this process where they like,
Where they heat,
yeah, it's like heat preserving.
but what happens is that you kill all bacteria off, and then you
Gotcha.
make it airtight. And then ideally, there is a shelf life on that. It doesn't last forever, but the canned and the jarred foods do have preservatives in them. So I guess we got to bring it back to Ms. Hedges. What did they say? Did they discuss any of the preservatives? Because obviously the preservatives also prevent bacterial growth.
Yeah, they said the MRE diet was like fully sterile, so they had a lot of preservatives and didn't have any like bacteria.
So is that why the MRE group gained weight?
Yeah, that could have been a reason. Yeah, because they didn't have any foods with like lactic acid bacteria in them.
Right? We've all heard about this before. Be very careful of processed foods. Um, you know, surprisingly, a lot of processed foods are the cold cuts and things like that. You think that they're fresh, but they have a lot of preservatives in them. I'm not saying to stop eating them. I love my ham and cheese. I'm just saying that you have to consider that when you're looking at the food. So, some of the things in the presentation discussed weight gain with MRE use. But again, if you're caught behind enemy lines, or you're in the Afghan desert, is it better to have food or not to have food? It's better to have food, right? It's better to have something to eat than nothing to eat. So now you have these MREs, they have processed a lot of processed, chemicals in there. preservatives to protect the food. Sorry. So you have a lot of preservatives in the MRE packaging to preserve the food for a long period of time. That's why I think most of the hikers or most of the mountaineering or that cohort likes the dehydrated foods, right? You take your filter, you pump out some water out of the river, whatever, or if you have fresh water coming from a running stream or something like that, you probably get away with it. And then just you boil the food, or you add water to it because it's dehydrated. That's why they like those. So those are a derivation of the MREs, the dehydrated food packaging. Now, this is where if we what would be very interesting is to find out. I'm going to assume in the dehydrated food, there's a lot less preservatives in that, due to the fact that once you take water out, which is the universal medium for things to grow in, right? Humans, earth, right, etc. Without water, we don't survive. So if you dehydrate, I'm assuming there's less preservatives in those packagings. When we go, I guess the best example would probably be looked at of what they did with the movie The Martian, right? When he had to take rations and spread them out. Obviously, a little bit of technical difficulty in that, trying to now that you're knowledgeable about the subject matter, you can probably go, oh, how did he get the water to rehydrate if he's on the planet? But he had the water producer, blah, blah, blah. But would there be enough water to produce or rehydrate the food all that period of time, etc.? Right? The whole idea there is if you're out in space, you still need kind of food, or you're out in extreme mediums, you still need a kind of food. So I just wanted everyone to think about this, because then you start thinking about the structure of the contents of the power bars. We've all seen or used those. So you have to consider what is put in those, the concentration, the high levels of maybe good fats per se, maybe a high concentration of protein, peanuts, what kind of sugar content. They're very, very, you can get really fat off those bars if you're not using them for their purpose, because they're so fatty. Good fat if you're playing or you need that high. And this is why I guess it comes down to rationing, as we discussed with Brian, right? The small little bottles, are what they're trying to show you. That should be what your dosing should be. An espresso or, whatever the energy drinks in small bottles, or maybe the brine from the pickles could be used, but they're in the small dosing, because, you get sick if you take too much of that. But again, even if you're performing or at the sport, you have to consider when, like I told you, I think if I told you my fly half, would stuff his face at 6 o'clock in the morning, and then before our match, vomit everything up. I don't know if that's the best, way of doing it, but that was his routine, because he couldn't, play with food in his belly. Again, very interesting when you start envisioning the resources of maybe the MREs, their use, their implication, the preservatives put in them to make them last longer. but also then the long period of time. But obviously, all of those items, whether it's MREs, whether it's power bars, whether it's dehydrated food, whether it's sustainability, is all dependent on whatever the water content and the potential for bacteria mitigation or keeping down the amount of bacteria so you don't get sick. But you still use them for a certain purpose. So maybe more that I just presented for you guys to all think about, but obviously you can see how easy looking at these power bars, and nobody wants to like dabble into looking at the power bars. But you got to be careful with those bacteria. Doesn't matter still. And botulism with the jarred foods and stuff like that, and Clostridium difficile. The jarred foods, that's why you throw away immediately any canned product or jar or food. If it's sealed and the bottle has collapsed, that means it's used the oxygen within it, and it's, there's a bacteria growing in there, so you don't want to eat that. Or a jar that's been jostled. If the can has been jostled, if the can has a dent in it, or it looks like it's, bubbled, like it's about to pop open, right? Either they produce a side product of carbon dioxide, or maybe they use the oxygen within it or use the carbon dioxide to build, bacteria, then it's sucking up the air or the whatever the air, whether it's carbon dioxide or releasing it, depending on the bacteria. All right, so you got to be careful with all those cans, but botulism is nothing to be, definitely go through your cupboards, remove all outdated products. Listen, they give you the date range to give you an idea. It's not a hard or fast rule. Obviously, I'm sure we've all eaten, a little stale bread, bread that's beyond its time window, right? Maybe, you heat up the bread with a little bit of water, you can still use it, but like I said, it's just a strong suggestion. But, be very careful with anything older than that. Go ahead, everyone, please.
Our third intern is Natalia, and she will be presenting on plyometric workouts in athletes. Natalia, when you're ready, may you please share your screen?
Thank you so much, Erin, for the introduction. I will share my screen now. Can you guys see my screen? Okay. So today I'll be presenting about the effects of strength, plyometric, and combined training on strength, power, and speed characteristics in high-level, highly trained male youth soccer players. And it is a systematic review and meta-analysis by John Oliver and colleagues, and it was in the Sports Medicine Journal in 2024. So, just a brief introduction. Soccer is a very physically demanding sport, and it requires a lot of strength, power, and speed to complete the movements like sprinting, jumping, accelerating, deaccelerating, and changing directions, which all happen during a match. One common way to improve these qualities is through plyometric training, which uses explosive movements. These exercises help athletes produce more force quicker and lead to improvements in jumping, sprinting, and their overall athletic performance. Although although elite youth soccer players engage in large numbers of soccer-specific training, there is not too much information on whether they would also benefit from resistance training. So this is what this article looks at. So the purpose of the study was to determine whether strength training, plyometric training, or a combination of both is most effective for improving athletic performance in high level, highly trained male youth soccer players. It didn't look into other athletes, it specifically focused on that group. Specifically, the researchers wanted to compare how these three different training methods affected lower body strength, horizontal and vertical jumping performance, sprint speed and acceleration, as well as change of direction. Um, and to determine if athletes who already compete at these high volumes are able to get benefits from this additional training. So to break down the different trainings, like I mentioned before, there were three different types that they looked into: strength training, plyometric training, and combined training. Each of the training methods lasted a minimum of 4 weeks. Because it was a systematic review, some of the studies went over 4 weeks, but they all had to have a minimum of four. For strength training, they looked at resistance training using body weights or external resistance. So some examples are free weights, medicine balls, elastic bands. For plyometric training, they didn't have super explicit things that they were doing. Instead, it was more seen as just explosive training. So they were either doing jumps, sprinting, and these are seen to improve muscular power, maximize their strength, and help increase acceleration. And then lastly was a combination of both. So this just combined both strength and plyometric training. So for the study design, the study was a systematic review, meaning that researchers combined results from multiple studies to provide an overall stronger conclusion. They searched five major databases and looked into studies published until June 2022. For the participants and which studies were used, they used a total of 34 controlled studies and a total of 1,396 high level, highly trained male youth soccer players. And all these players had to compete in academy, national, or elite programs to qualify as a high level, highly trained soccer player. Recreational athletes, female athletes, adults, and injured players were excluded from this study. And if a player was injured but still qualified in that high level, highly trained, they were not included just because they wouldn't be able to do the testing. And then for the interventions, like I mentioned, they had three resistance trainings, and each of these trainings lasted a total of at least 4 weeks. Some lasted longer, between 6 weeks up until 12 weeks. And each of these intervention groups was compared to a control group that just continued their regular soccer training without any additional interventions or trainings. So for the results showed that all three of these training methods did produce significant improvements in athletic performance when compared to the athletes that continued their normal soccer training. This suggests that adding a structured and resistance training program provides benefits beyond just soccer practice alone. When looking at the specific outcomes, strength training produced the greatest improvements in lower body strength, making it the most effective option for increasing force production. Plyometric and combined training were effective in improving jump performance, acceleration, and change of direction speed. These are all qualities that are super important in soccer and things that happen constantly during a match and practice. And lastly, for sprint speed, there was a improvement with all three of the methods, but it wasn't as significant as some of the other results that they found. So in this case, they just kind of decided that all three improve it, but there's not a specific one that works best. But overall, all three soccer training interventions were successful in improving athletic performance. For the strengths of the study, they did include a pretty large sample size of 34 studies and nearly 1,400 athletes. They also used a systematic review and meta-analysis, which combined evidence from many studies instead of just relying on one singular one. They compared three different training mechanisms and gave different results for different performance outcomes. And these results can provide recommendations for coaches and strength professionals that work with these athletes. For the limitations, it did only include high-level, highly trained male youth soccer players, so that limits the population that this could be applied to. Like I mentioned before, athletes that are female were not looked into this, as well as adults or recreational players, so this is only really applied for that high level. Another limitation was the training programs were not identical across the studies that were used. Some of them lasted 4 weeks, some of them were up to 12 weeks, and the training intensity, exercise selection, and training frequency was not consistent. The variations make it a little bit difficult to compare how accurate these findings are. The intervention was also short term. Since the minimum was 4 weeks, that isn't really enough to give researchers the long-term effects of these interventions. And then lastly, there was evidence of some publication bias that was identified by the authors. This means that some of the studies that were used reported positive or significant results that were more likely for publication reasons, and this could slightly overestimate how effective these training methods appear overall. So just some key takeaways. Overall, the review showed that resistance training is an effective way to improve strength, power, and speed. The findings suggest that strength training is the best option for lower body strength, while plyometrics and the combined training is more effective for jumping ability, acceleration, and when it comes to changing directions. Based on the results, coaches should consider incorporating a variety of these trainings into their programs as it can help these athletes with their overall athletic performance. And like I mentioned before, it is important to remember the study's limitations. The sample included only high-level, highly trained male youth soccer players, so these findings cannot apply to everyone like female athletes, other age groups, and different levels. And with the publication bias, that may make the findings a little bit inaccurate on how much they were improving these different strength, power, and speed in these athletes. So that is just an important thing to remember. This is my reference, and thank you so much.
Thank you, Natalia, for an interesting presentation. Does anyone have any questions for her or yeah, Jack?
Thanks for the great presentation. I was wondering, did they specify like the age range of the like because they said youth soccer players, did they
Yeah,
specify like specifically the range? Because I know like for the training types and also for like how their bodies result from the training, like a 10-year-old could be very different from like a 16-year-old, did they?
yeah, so it depended on what level they were, if they were club, if they were higher than club, like depended on the level, but the ages went from 10 up until like 16, 17. But it was broken down into like which specific program they were actually in.
Got it. Thank you.
Yeah.
All right. Well, I'm glad that the manuscript came up with the assumption of multi system training. That's pretty much the direction of what they're doing right now. Obviously, to try to gain the different, whether it's strength, jumping, acceleration, deceleration, changing direction, or even just in general, speed and power. The importance is that you have to incorporate all. That's why, if you notice, we always inquire whether or not there's conditioning, right? There's always a side of conditioning that an athlete will do on their own, where they focus on, I think the lateral slide, that was incorporated for a bit. Do you guys, anyone know? You know what, Chris, you probably know what I'm talking about. That little, it's like you unroll it, and it's almost like you put socks on and you practice the slide skating left to right. That was incorporated quite a bit in training to get that endurance and strength. But I think it's the resistance. I think the slide itself incorporates speed, resistance, and strength. So it's like you can get 2 for 1 with that for a cheap cost, right? If you had to buy it for your team, or you had to, or if you were just training at home, you could probably incorporate both of those. The thing is, it mimics, skating. But the thing is, in the big picture, doing those plyometrics, which are kind of, you almost have to have instruction for some of those. And if you're not following technique, if you're not recording yourself, evaluating whether or not you're following good technique, obviously on the driving range, you've seen, whoever's gone out to the driving range, they set that, your phone up to evaluate your swing, keeping your chin to your chest, making sure your form is proper. You got a really good swing through. The whole idea is that you can do these things, but obviously, if you're not self-reflective, or if you're not evaluating yourself or being evaluated, there could be limitations on your technique. And obviously you may, not following form correctly. That's why if we take what they're proposing here, which is the ideal setting, right? We talked about this. It's great to do this in an ideal, bubble, doing it on a linear running treadmill. We talked about that, right? But then when you take it out to practice, you have to be a little bit more, lenient in your parameters and trying to get a, ideal injury prevention plan, or maybe even get them to be adherent to the exercise programs.
That will conclude week 7 of the RISE Institute and Rugby Research and Injury Prevention Group Sports Science Series. Thank you all for attending.